In this program, we'll review maintenance, external adjustments, and the basic diagnostic procedures that apply to Daimler-Benz automatic transmissions. Component replacement and overhaul won't be included. The service microfiche covers this information in detail, and you should refer to it when performing any repair operation. Also, if you're not familiar with the basic operation of an automatic transmission, it would be a good idea to view the previous Education for Excellence program covering the principles of operation before viewing this program. Basically, it can be said that there are 3 generations of Daimler-Benz automatic transmissions. The first generation was introduced in 1961 and can be quickly identified by the solenoid on the top. This is found in vehicles such as the early 111 series, the 280 SL, and a reinforced version was used in the 300 SEL 6.3, and also in the 600 limousine up to the end of production in 1981. The second generation transmission was introduced in 1968 and is visually very different from the previous version. And of course, it has no solenoid, which is very obvious. You'll notice it has separate converter and transmission housings. Examples of models using the second version are the 450 SE and the 450 SL, and as late as 1983 in the 300D turbo diesel. Finally, the third generation transmission is the one currently being produced, and although very similar in appearance to the second generation, can be quickly identified by the one-piece housing. When it comes to service and repair, it's of course necessary to identify the transmission more specifically than by generation, since everything from the fluid quantity to adjustment specs may vary depending on the exact version. Second and third generation transmissions use the factory 722 number to provide an exact identification. And with the exception of some factory remanufactured units, you'll find the complete 6-digit 722 identification number stamped into the housing. The second and third generation transmissions have 5 families, which are identified by the 4th digit. And the exact vehicle application is identified by the 5th and 6th digits, such as the 358 series, which is installed in the USA Model 300E, beginning 1989. Any discussion of the basic service of an automatic transmission must of course begin with the automatic transmission fluid. There are 3 things that you must be concerned with. The first, of course, is determining the proper level. The second is following the correct procedures for replacing fluid and filter. And the third is using an approved fluid. First, regarding the level. All transmissions, of course, use a dipstick with a maximum and a minimum mark. And when the fluid is at full operating temperature, with the engine idling and the transmission in park, the level should be somewhere between the marks. In practice, though, it's very seldom that you'll be able to check the fluid when it's at operating temperature. The fluid temperature will most often be at shop temperature, or slightly above. A rule of thumb you can use is that if the dipstick feels neutral from a temperature standpoint, in other words, not noticeably cool or warm, the fluid should be near the 70 to 90 degree range. And within that temperature range, a correct level will be considerably below the minimum mark. For example, the 722.3 will be 10 millimeters below the mark, and the 0.4 just slightly less at 12 millimeters below. But the level in the 722.0 and 0.1 is correct if it's a full 30 millimeters below the minimum mark at shop temperature. This special funnel is used to add fluid. It has a mesh filter and fits the dipstick tube properly. A word of caution. Depending on the version, the amount between the maximum and minimum mark may be as little as 10 fluid ounces or slightly more than 1/2 pint. Because the amount between the marks is so small, it may happen that the transmission is mistakenly overfilled, which brings up an important point. The transmission must not be operated while overfilled, since the possibility of damaging the transmission is just as great as if it's underfilled. Overfilling the transmission will cause the fluid to aerate or foam, which will lead to slippage and overheating. This special extractor is available for easily removing excess ATF and is a required special tool. The next consideration is the proper procedure for changing fluid and filter, which under normal operating conditions is recommended at 30,000-mile intervals. Job 2702 in the maintenance manual covers the necessary information in detail, and much of it is fairly common practice that would apply to any automatic transmission. Although there is one important point that you should be aware of, which is that Mercedes-Benz uses a torque converter with a drain plug, and it must be drained also. Initially, refill with the quantity specified, less 1 quart. Idle the engine in park, then shift the transmission into forward and reverse gear. Leave it in each position several seconds to allow the apply units to refill completely. Finally, top off to the correct level for shop temperature conditions as explained previously. The third and final point regarding fluid maintenance relates to the rule that only factory tested and approved ATF should be used. The fluid must be compatible with the friction linings used in the transmission, so it's critical that only an approved fluid is used. Using a fluid that isn't compatible can lead to complaints such as harsh engagement or slipping. You'll find approved ATFs included in a listing of all factory-approved lubricants, which is released periodically as a service information found in Group 00. Next, we'll look at the 3 external checks and adjustments that control the shifting characteristics of the transmission. 2 apply to all vehicles, and the third applies only to diesels. The adjustments we'll discuss have a great influence on shifting, and complaints are often due to problems with these adjustments. A good rule to follow is to check the fluid level and condition first, then check the external adjustments. Although they're easy to check, they're sometimes overlooked. We'll begin by looking at the control pressure adjustment, since it's a simple visual check, and also the easiest one to correct. But first, let's briefly consider what the adjustment affects. As explained in the Theory and Operation program, the control pressure opposes governor pressure to influence the shift points. And the control pressure valve is operated by the throttle linkage with a cable or rod. Checking control pressure is therefore simply a matter of determining if the cable or rod is correctly adjusted in relation to the throttle linkage. In fact, you should first determine whether the throttle linkage is in order, since the control pressure linkage is operated by it. This begins with a visual check to ensure that there are no problems, such as bent or worn linkage. The linkage should operate freely. If it's been neglected, you may find rusting pivot pins or sticking ball joints that need attention. The next step is to confirm that the idle and full load stops are being reached. On a gasoline engine, the stops are on the throttle valve housing. On diesel engines, the stops are on the injection pump. By the way, the full load check requires 2 people, since it should not be done by operating the linkage under the hood, but from inside the vehicle by depressing the accelerator pedal to the point where it just touches the kickdown button. A second person should then observe whether the full load stop is being contacted. If either the idle or full load stop is not being reached, and there are no mechanical problems with the linkage must be adjusted. This can get involved, so to be sure it's done right, refer to the service microfiche for the particular engine type. Group 30, Job 300, covers the entire throttle linkage adjustment procedure in detail. After you're sure that the linkage is okay, you proceed with checking the control pressure adjustment. As mentioned previously, there are different types of control pressure linkage, depending on the vehicle type. But all current vehicles use a control pressure cable. In principle, the basic setting is the same for all vehicles. Let's look at a V8 engine as an example of what you would check for. First, the connecting link is removed. Then the control pressure cable is pulled forward just to the point where all the free play is removed and a slight resistance is felt. In this position, the connecting link should fit tension-free. In the case of this particular design, if an adjustment is necessary, it's made by adjusting the length of the connecting link. Remember that for each vehicle type, Group 27, Job 110 in the service microfiche will explain the control pressure linkage adjustment in detail. Also keep in mind that the transmission section of the diagnostic manual has linkage adjustment and other diagnostic information for some models, and is being expanded to eventually include all recent models. To summarize, it should be repeated that if the control pressure linkage is misadjusted, it will cause incorrect shift points. Always check the adjustment first when you encounter that type of complaint. The next external adjustment we'll look at involves the modulator pressure. You'll recall from the theory and operation program that the modulator pressure is responsible for controlling the firmness of the shift. Unlike the control pressure that we've just covered, it does not have an influence on the shift points. It will only influence how hard or how soft the shifting will be. The modulator has an external adjustment, which in the case of all later transmissions is accomplished by this key. If the key is engaged and turned clockwise, the modulator pressure increases, and the result is a more firm shift. If turned counterclockwise, the pressure decreases, and the shift will be softer. The modulator pressure can be measured using a gauge and adjusted to a precise pressure value. The procedure for checking and adjusting modulator pressure will be covered later when we discuss the road test. The third and final external adjustment applies to the modulator vacuum control valve used on vehicles with a diesel engine. This component was introduced in 1978 on the 300 SD. It was provided as a means of improving the shifting characteristics by allowing the use of a vacuum-operated modulator. The purpose of the valve is to provide a certain vacuum signal depending on injection pump opening. Therefore, checking the valve is a matter of determining if a specified vacuum is provided at a specified pump opening. The exact checking procedure and specifications vary by model, and even model years in some cases. For that reason, we'll only look at the concept of checking adjustment in a general way. For specifics, you should refer to the automatic transmission section of the diagnostic manual. Now, the initial check is to determine if the link rod is adjusted to the correct length. The latest version rod is 118 millimeters, measured as shown. Then, with the link rod installed, the pump lever is held against the full throttle stop. At that point, there should be no more than half a millimeter clearance. If the adjustment is not correct, the ball head is loosened and moved in the slot as necessary. The next step is to determine whether the vacuum valve is regulating the vacuum correctly. To do this, disconnect the rod. Connect a vacuum gauge into the line at the vacuum damper. Now, the connection point differs depending on the model, so be sure to refer to the published procedure, or you may be measuring the wrong vacuum circuit. Now, you'll need this special adjusting roller, which is available through the special tool program. Mount the adjusting roller on the valve stop pin. Run the engine at idle and hold the valve lever against the roller. The vacuum reading should be within the value specified, which will depend on model and model year. The later version valve is adjustable, and if it's out of specs and only requires adjustment, the cap can be removed and the tension on the coil spring changed. This special tool is available for adjusting the later version valve that doesn't have an adjusting set screw. Always recheck after the valve is adjusted. Operate the lever several times to confirm that the valve is not sticking and that the reading remains constant. The final check is to remove the adjusting roller and hold the lever against the stop pin. In this position, the vacuum reading should be at 0. Okay, that's a brief overview of the procedure for checking the vacuum control valve used on a 61 series diesel engine. Now, let's move from the 61 series diesel to its replacement, the 60 series engine. A new version vacuum control valve was first introduced in 1984 on the 601 diesel engine. The valve is operated directly by the injection pump throttle shaft, eliminating the link rod and making the checking and adjusting procedure much simpler. To adjust the valve, first, loosen the 2 mounting screws. Then, the pump lever is held at full throttle and the valve is turned clockwise, just to the point where spring resistance is felt. The valve is then tightened in that position. And that's it. Nothing further to check. The vacuum control valve greatly improves shifting characteristics of diesels. But another improvement to the vacuum control system was introduced in 1985, which fine-tuned the shifting even further. This component, the vacuum amplifier, is installed in the transmission control circuit and modifies the vacuum signal to compensate for two important factors: temperature and turbo boost pressure. The procedure for testing the vacuum amplifier is included in the vacuum control valve test that we just discussed. Just to briefly review the test, you would check out the electrical control circuit first, starting with the temperature switch, and then the electrical function of the switchover valve. If the temperature switch electrical circuit tests okay, you can now test the vacuum amplifier. You'll need the combination vacuum and pressure tester provided as a Mercedes-Benz special tool. First, unplug the vacuum line going to the transmission. The connection is marked TRA. Tee in the vacuum gauge line. Next, unplug the boost pressure line coming from the injection pump. The connection is marked PRE. Hook the tester pressure line directly to the connection. Idle the engine and simulate 740 millibar boost pressure. The vacuum reading at the transmission connection should be 40 millibar with a plus or minus 20 millibar tolerance. If the reading is out of tolerance, replace the amplifier. Okay, that summarizes the vacuum control circuit testing necessary if the vehicle is diesel powered. And in general, we've now covered the more important under-the-hood checks which may be the cause of a transmission complaint. Let's assume everything is checked out under the hood and you haven't found anything that would cause a problem. You would now consider pressure testing. There are two things that you'll require to perform a pressure test: an accurate pressure gauge set with the necessary fittings, and the test sheet that applies to the vehicle you're testing. A copy of each test sheet covering models through 1989 is included in the book with this video program. Let's select this test sheet and explain its use. This sheet is identified by the transmission type and the model year or years that it applies to. Now, looking at the sheet, the preliminary checks in the first section are just a reminder to check the things that we've already discussed, such as the transmission fluid level, and in addition, the appearance of the fluid. Check to see that the oil is clean. If the oil is cloudy or has a burned smell and appearance, you shouldn't attempt any further testing without first determining the extent of damage. To inspect for damage, drop the pan and check for residue in the bottom. If there are particles of burned band or clutch lining or metal shavings, there's no need to test any further. The transmission is damaged and will have to be repaired or replaced. If you find the fluid level and appearance okay, checking the adjustment of the control pressure cable is listed next. We've already discussed the importance of that adjustment and its effect on shift points. And the last preliminary check listed, if a diesel, is the adjustment of the vacuum control valve. We've also discussed the importance of that adjustment and its effect on shift quality. The performance or road test is next and is used to confirm the complaint. First, as noted, all of the testing is done in position D. The vehicle model is located on the chart. Then the vehicle is driven on a level road or on a dyno simulating a level road. And for example, with light throttle acceleration, the upshift from second to third gear should occur at 18 miles per hour. Checking the speed at which the downshift occurs requires maintaining a light throttle but increasing the load as necessary to force a downshift. Now, if the test must be done on the road using care, you'll have to apply the brakes to provide the load needed. Of course, on a dyno, simulating the exact load needed to force a downshift is no problem. When the necessary load is reached, the light throttle downshift from third gear to second gear should take place at 11 miles per hour. The test includes checking the shift points in the same manner under full throttle accelerator position, which means that the pedal is just touching the kickdown switch. And finally, at kickdown, which is, of course, with the accelerator fully depressed, kickdown engaged. Now, a word of caution. If on the road, don't exceed the legal speed limits, or if on the dyno, don't perform the full load kickdown test. In fact, there's no need to. If there's a problem with shift points, it'll already show up while testing in the lower gears and the lower speed ranges. Okay, the performance test has confirmed the complaint. Now we can proceed with the pressure test. Any one of the several different shifting complaints would require pressure testing before a diagnosis of the possible cause can be made. So let's go through a hookup and test of the three pressures involved. Most of the time, depending on the problem, you'll only be interested in checking one or occasionally two of the three pressures. For example, only governor pressure would be checked if the transmission can't be shifted into reverse or park with the engine running, or if the transmission won't upshift, or if the shifting occurs too soon or too late. These complaints would warrant a governor pressure test. Checking working pressure is limited to basically two specific problems: if the vehicle does not move at all, or if there is slippage, usually extreme, during all shifts. And finally, modulator pressure, which is probably the most commonly tested pressure, is only checked when the firmness of the shift is the complaint. The gauge set Mercedes-Benz provides is designed to hang from the mirror. The hoses are routed out of the window and secured underneath to ensure that they don't touch the hot exhaust pipe. The location of the three pressure ports is the next thing you have to know. And let's identify them on the current version. The modulator pressure port is easy to identify because it's right next to the modulator. The governor pressure port is at the forward left of the transmission, here. And the working pressure port is the fitting on the right side, here. The retention book has illustrations showing the current and previous transmission pressure ports. For best accuracy, it's preferable to check modulator or governor pressure using the gauge that reads up to 10 bar. The higher pressure 25 bar gauge must be used for measuring working pressure. The lower pressure gauge should not be used as it may be damaged. Again, there is no firm sequence for testing the three pressures. The tests will depend on the complaint. So let's start by explaining the working pressure test, since it's the simplest. First, the 25 bar gauge is connected to the working pressure port, and the modulator vacuum line is removed and plugged. The engine is started, the parking and service brake applied, shift to D, and raise the engine speed to approximately 1,000 RPM. The pressure value is read and compared to the specified value on the test sheet. Now, let's assume that the pressure is out of specs. What would the most likely causes be? Well, first of all, you'll remember that in the theory and operation program, it covered how the modulator pressure controlled the working pressure. So, obviously, the first consideration would be to check the modulator pressure, which may require a simple adjustment. The next consideration would be a sticking working pressure control valve, which would require removal of the valve body to determine if the valve is at fault. And finally, although uncommon, the front pump may in fact be inoperative, which requires removal of the transmission for inspection of the torque converter drive lugs and pump assembly. Normally, though, the pump either provides sufficient pressure or it doesn't work at all. And when it's the cause of insufficient pressure, you will find definite signs of damage. Now, let's move on to checking the governor pressure, which is also a fairly simple test. But now the vehicle will have to be driven. For testing governor pressure, the 10 bar gauge is connected to the governor pressure port. You'll remember that it was mentioned earlier that a defective governor may prevent the shift lever from being moved to park and reverse with the engine running. There should be no governor pressure at idle. So if pressure is present at idle with the vehicle at a standstill, the governor is sticking and is the cause of the problem. If the complaint is no upshift and the governor is at fault, it would be confirmed by the fact that no or very little governor pressure would be registered regardless of road speed. And finally, incorrect shift points is the last complaint that may be caused by the governor. And to check for that possibility, the vehicle is driven first at 18 miles per hour and then at 55 miles per hour. And the governor pressure should be as specified on the test sheet. If pressure testing indicates a problem, the governor should be removed and inspected to determine whether it may simply require cleaning or is defective and must be replaced. That leaves only the modulator pressure test to discuss. And that test is probably performed most often, since it influences shifting quality, how hard or soft the shift is. Accuracy must be emphasized when performing the modulator pressure test. In fact, the modulator pressure value is so critical that a plus-minus tolerance is not given. The gauge must be accurate, and the test should be performed exactly as specified. The first step is to remove and plug the vacuum line to the modulator. This ensures that the pressure value is measured under an absolute full load condition. Connect the 10-bar gauge to the test port. Operate the vehicle in D at 30 miles per hour. Read the pressure value and compare to the value specified. As discussed earlier in this program, if an adjustment is required, the adjusting key is pulled out to unlock it and turned clockwise to increase modulator pressure, which would result in a firmer shift, or counterclockwise to decrease the pressure, which would provide a softer shift. Once the value while driving has been determined, if an adjustment is necessary, it can be done accurately at idle in park. Although the gauge reading may not be exactly the same when driving and when at idle, the adjustment effect is the same. In other words, a 1/10 bar pressure adjustment at idle will change the pressure while driving by the same amount. Oh, by the way, when you're performing the modulator pressure test, pay attention to the firmness of the shifts. Since you have the vacuum disconnected, the modulator pressure is constantly at its maximum value, so the shifting should be quite firm. Therefore, if slippage is evident, you should suspect an internal problem in the transmission and not a simple vacuum control or modulator problem. That's a good tip that could save you time when performing a diagnosis. Well, that summarizes the objectives of this program that were stated at the beginning. We've covered maintenance, external checks and adjustments, and the basic diagnostic procedures that apply to Daimler-Benz automatic transmissions. Before closing, let's quickly review the sources for transmission information, since there are several available that can be of great help to you. First, the book included with this program has a brief summary of a lot of the basic points that were reviewed in the program, which is information that you might need on a daily basis. Then there's the Service Microfiche Group 27, which is the most complete source for information covering all aspects of service, maintenance, adjustment, and complete overhaul instructions. The Technical Data Book contains tightening torques, testing data, and other specifications. The Diagnostic Manual provides comprehensive step-by-step diagnostic procedures and is in the process of being updated to eventually include all current version transmissions. Service information found in Group 27 provides the most current information on recent changes and, in many cases, detailed work instruction for performing modifications to improve transmission operation. And finally, the Diagnostic Directory, or Red Fiche, contains the most current summary of known complaints and their possible causes and remedies. There's a lot of information in these different sources, so don't forget to use them. And we'd appreciate your comments on this program so that we know if we're meeting your needs. Please take a minute to fill out the enclosed response card and drop it in the mail. Thanks.